All right, welcome back. And today we are going to do a question called longest increasing subsequence. You're given an array of integers, return the length of the longest increasing subsequence, not necessarily contiguous in an array. So what a longest increasing subsequence is that can you give me a list of like numbers within this array that goes from left to right? It doesn't need to be contiguous. That means it doesn't need to be all stick together like this. Can you give me something like that where the number of elements in that subsequence is the highest? So for example, if we look at this, the longest subsequence would be 0, 2, 6, 9, 11. So as you can see, I went from left to right. So that's what a subsequence is. Like for example, if I choose 0 and 8, the longest subsequence would be 0, 8, maybe 10, 11, and then 15, right? So you cannot go lower once you choose a number, and then you just have to go through it, and then you have to find which subsequence is the highest. Yeah, like how many numbers there are. So the great thing here is that we don't actually need to output the subsequence itself. We only need to output the size, like the length. So that would give us a hint. Usually questions like that, it's related to either recursion or dynamic programming. So this question is a dynamic programming, and because we have an array, that also gives us a hint. It's that we can store information about the array as we go and then use that information back. For example, let's think of, actually let's go to the drawing board. Yeah, so don't look at cache for now. This is kind of a hint, but don't look at this for now. Just look at the input array. Imagine if I was 10. Imagine if my array was this size, right? Just like this size. And at the end, I want to know. So technically, the size of this subsequence would be, what are the longest subsequence here that at the end of the subsequence is smaller than my number? If that's the case, then the subsequence here, the longest, is that one plus 1, which is myself, if that makes any sense. Yeah. So imagine if I already have the answer for the longest subsequence for this array, this array, this array, this array, right? Like what I mean is like I have the answer for this array, like 0. I have the answer for 0, 8. So for example, if the answer for 0 is 1, because I can only get 0. For this subarray, it's 2 because I can have 0, 8. For 4, it's also 2 because I could only go 0 and then 4, or 0 and 8. That's it. That's the max size. And then for 12, let's see, it's 1, 2, 3, or 1, 2, 3. So it's 3 here. But another way of looking at it is I could have said, okay, well, what is the longest subsequence in all of these arrays? Like if it was a 1 array or 2 array or 3 array, then what was the longest? Then I see that 2 is the longest, and then I also check, is the last number of the subsequence smaller than me? If it is, then I could add 1 to it, right? So that's pretty much what you do, and then that's exactly it. That's dynamic programming. So let me do the whole array just to make it clear so you can understand what I'm doing and what's going on. So like I said, okay, 0. I start with 1 element, so that's easy. It's just 1. And then max currently is 1. Max, we're gonna calculate this for each iteration. So for example, 8, we're now at this guy. Okay, we're at 8 now. So what I'm gonna do is I'm gonna look at the pass element. Okay, so there's 1 here. Excellent. Am I bigger than 0? Yes, I am. So what I can do is I can add 1 to this number. So it's 2. Okay, and then now I'm at 4. I'm at this guy now. And then I do the same thing. I iterate over the whole thing. So currently the max is 1. Am I smaller than 0? Yes, it is. So max is 1. And then I check for the next one, which is 2. Oh, awesome. Am I smaller than 8? No, I am not. So max is still 1. And then that's it. I'm done this iteration. So I could do 1 plus the max, which is 2. All right, let's do 12 now. 12, I look into this array, I look at 1. Okay, so now max is 1. Okay, am I smaller than 0? Yes, I am. All right, is 12 smaller than 8? Yes, I am. So what is the value here? It's 2, all right. Oh, 2, excellent. So now I got 2 plus 1, so that would be the max. Okay, I guess 3, like this. Okay, oops, darn it. So actually, I could just keep the max as 2, because we're just gonna add 1 later, and we're gonna keep it as max here. And then I'm gonna look at the other one. Am I smaller than 4? Yes, I am. 2, but 2 is the same as the max, so it's fine. And now I add 1 to it because of myself. All right, cool. Now we do the same thing with 2 now. Let's look at from the beginning. All right, 1, am I bigger than 0? Yes, I am. So now the max is back to 1. Okay, and then I look at 8. Okay, I'm smaller than 8, so I don't do nothing. I'm smaller than 4, I do nothing. I'm smaller than 12, I do nothing. So here max is 1, so 1 plus 1 is 2, right? So we do the same thing with 10. We do 0, same thing. We are bigger than 0, so 1, so max is currently 1. Am I bigger than 8? Yes, I am, so now max is 2. And then we look at 4. Am I bigger than 4? Yes, I am, but it's only 2, so max is already 2 right now. 12, it's 3. Unfortunately, I'm not bigger than 12, so I cannot update this to 3. And then later on, you'll see I get 3. Same thing. So we could do this faster now, but we could do 6. Okay, it's bigger than this number. Okay, it's 4. It's bigger than this number. It's 2. Okay, so this would be 3. And then 14, it's bigger than 8. Excellent. Okay, so the max is 2. It's bigger than 12. All right, the max is 3. It's bigger than 10, which is 3, but it's already 3. These are all the biggest 3. Okay, it's fine. So it's going to be 4 here. 1, we're going to do again. So it's bigger than 0. Excellent. But that's it. It's only bigger than 0. So we're going to have 2 here. And then 9, we're going to look at, okay, it's bigger than 8. That's 2. Okay, that's cool. Is there any number that is smaller than 9 but has a bigger number here? No. So 8 is 3. Yeah, and then we finish, let's see, and then, wait, did I do something wrong? I did one thing wrong here. 9 is bigger than 6, and 6 is 3, so 9 should be 4. And then we continue doing this, 5, let's see, it's bigger than this, 2, it's bigger than 4, so it's 3, and then 13, I could do it quickly, it's bigger than 9, 9 has 4, so it's 5, and then 3, it's, let's see, 2, is it 2 here? Okay, it's probably 3. So then the answer would be 4, right here. Yeah, so then this would be your longest subsequent, so that's the result. All right, cool. So now let's talk about the time complexity. So the time complexity, what do you think it is? Well, first we have to go through the whole input one by one. And for each of this value, we go through the cache one time. So that's O of n movement here for this array. And then for each time we go through a loop, that's another O of n. So that means O of n times O of n. So that makes O of n squared. And then space complexity, we need this cache. So that's linear O of n, because this cache will be as big as the input, which is O of n. So space is O of n, time is n squared. All right, so that's pretty much it. Let's code it up. So the first thing we do is we make sure that there is something in the array. So that's just the base case. We're gonna return 0 if not. And then what do we want? We first want the cache array, okay? So we'll all set it to 1. Oops, because that is the minimum amount you can get, because if you're a single number, you're number 1. So us, instead of keeping a max, we're just going to use the value itself on the array as the max, because it's going to be a lot easier and you don't need another extra variable. So first, what do? We iterate through the array. So in range 1 length array. Okay, so we iterate through all the array. And then for each of the value, like we did last time, we're gonna iterate through the cache. Okay, so we're gonna iterate through the cache until our own value. Okay, so now what we want to do is we only do something if the current value is bigger than the value on your left, wherever you are. And then if it is, then your new max, we're gonna call it cache I because it's we're just skipping the max, is gonna be the max of whatever the value is, like currently. So this is basically the max, cache I is the max. Or if the value that you see plus 1 is bigger than you, right? So if it's bigger, then you update the max. That's pretty much what that does. So instead of using the max variable, we're just gonna keep it in the cache already. And then at the end, you just return the max of your cache array, and then that would be your longest subsequence. So let's try it out here. This should give you 6. This array is kind of the same array as the example, except that in the example, I stop here because I just didn't have space anymore. So it should give you 6. Oopsies, forgot it's Python 3. All right. And then there you go, it's 6. Now, one thing we can do is to make it easier to understand, we could also print the cache so that I could kind of illustrate to you what it looks like. So remember on our example, it's 1, 2, 2, 3, 2, 3. That is essentially what you're calculating. And then in the end, you just take the max of this whole array. It happens to be the last element, but it might not always be like this case. But yeah, so that's the whole cache array. And yeah, that's pretty much it, this dynamic programming. All right, I hope that was interesting, and I'll see you next time.